Okay, so let's quickly solve another task. We have in roadmap, so we have copy list with random pointer. So what we given? So a linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list. Okay, or null. We have construct a deep copy of the list. The deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of its corresponding original node. Both the next and random pointer of the new nodes should point to the new nodes in the copied list, such that the pointer in the original list and copied list represent the same list state. None of the pointers in the new list should point to the nodes in the original list. All right, nice. So for example, if there are two nodes x and y in the original list where x random points to y, then for the corresponding two nodes x in the copies x random, and we have the return as a head of the copied linked list. The linked list is represented in the input and output nodes. Okay. Your code will only be given a head of original linked list. All right, so how we can actually solve it? So the main idea is that we can store the map between a node original to node copy. Yes. So we just go and we create like this copy node. So that's something that we actually can do. And then, so first we just create this node. So after we create a map, second step, we create a copy. So by copy, we just go, we already have a node, right? And we have a head, and also we have a head and we have a current node. And current node just go and like modify this head and creates like the next one and so on. Yeah, so how it works. So for example, we have some original nodes, and this one, for example, points to 5. This one points to 1, and so on. And what we do, we first create a map where we have 1 equal to new 1, 2 to new 2, and so on. And after this, we have a head, this head, and we can do like recursive call, I believe, or we can do recursive call. Yeah, because if we, for example, take a head from here, then we have a copy 1, right? So we took a copy 1, but we need to make this communication. So that's why we need actually the next node. So we can actually go by recursion. And can we go by recursion? Actually, yes, because the maximum is 1000 nodes. So yeah, let's create this recursion call. So it will be like DFS. So first we have our map with node to node. It will be our hash map. It's where we just iterate while, and we have node current, it would be head, and while current not equal to null, we put into our map yeah, and also we can store like node previous, that would be null. And yeah, so actually we can put into our map the current node, and here it would be new node. Yeah, let's create actually. Yeah, because we need to have the next, and we should update the previous. So yeah, so we just create a new node here, and here it will build a new node with current value, right? Yeah, and here we can like create this new node. It would be previous, then yeah, so then current becomes current next, and yeah, I think it's can we do it actually. So because we need to get next, and we have previous. Yeah, we have previous, we current next. Here we can check if previous not equal to null. Here it can be like new node and node, and yeah, we always create new node here, and if previous not equal to, then previous next equal to new node, and here we put a new node, and yeah, and we update actually previous to, we should update here previous to current, to new node. Yeah, and this way we are done with our map. And then what we also can do here, we can again create current, update actually our current to head, and again iterate while current not equals to null, and here we can do like car random equals to map get here not, yeah, so here it should be a map get current random equals to map get map get current random okay, so what we can do here, we can do like map get head. It would be node result, so it's our result, and then then current would be equal to result, and then while current not equal to null, we should go like result random equal to map get result random. Here we don't have random, right? Yes. Yes, we have only value and random. So previous next and new node. We can also check if current random not equals to null. We can do like a node random equal to current random. Yes, in this case we iterate and we just get from here and we return results. Something like this. Yeah, it looks quite complex. Let's verify that it works. Do I have some issues here? Yeah, we have copy. So we just create, then take from current next current randoms, and we put into the map, right? So we did this actually copy, then we populate random. Yeah, actually the same as we did here. We can maybe do it like this. So we would copy, then copy infer from head. We have this map here. Then we implement this node copy where we had node, and yeah, and here we put into the map. So we create actually the new node. It would be node result, and yeah, it would be node result with node value, then result random equal to node random, and result next equal to copy node next. Correct? It's correct. Yeah, copy next. And yeah, we need to have here if node equals null, we just return null. So the base case, and then we put into the map our node with result, and then we return results. So here we have this copy, then we need to populate random R and D, with copy, and then we return actually this copy from here. So how we populate this R&D? So here we have our node function. Let's put the function name, and yeah, and here if node equal null, we return null. Otherwise, node random equal to map get yes. Node random map get node random, and then we just do it for all nodes, and yeah, that's it. That's me. Yeah, and we see that it accepted. We are 100% solved. So yeah, we check our previous code. So basically it works this way, right? So we copy first, then we populate the random values, and we just return this copy. So that's it. Thank you.